Hello everyone, this is Mr. Underkoffler, and today we are looking at the guided notes on dividing fractions and mixed numbers. As you can see here at the top, I have the rules spelled out for you here. You have to immediately convert whole numbers or mixed numbers to improper fractions before you do anything else, if you are given a problem with whole numbers and mixed numbers with division. Here's the main rule. Division is the same as multiplying by the reciprocal. It's kind of like the idea of how I taught you before that subtraction is the same as adding the opposite, where the first number would stay the same, and then you made subtraction become addition, and the very next number become its opposite. Very similar here. The first number will stay the same, division will become multiplication, and the second number will become its reciprocal. If you don't remember what a reciprocal is from 6th grade math, you will see very soon once we get to some examples. Now, we learned in the previous guided notes that there was a cool trick with multiplying fractions, and that was being able to reduce diagonally, so to speak, where you could reduce any numerator and any denominator by a common factor before you actually multiplied. So you might be asking yourself, well, is this something that we can do when there's division? The answer is no. You cannot reduce diagonally when there is a division symbol in between. But once you rewrite the problem as multiplying by the reciprocal, then you will have multiplication in between, and then you will possibly be able to reduce diagonally if there is a common factor that you could reduce by from a number in the numerator and a number in one of the denominators. Then you could. All right, let's take a look at some examples. Now, number 1 and number 3 are already typed up for you on your guided notes, but follow along. We are finding each quotient, which means we're finding the answer to the division problem. As we learned at the top, division is the same as multiplying by the reciprocal. So here's how we do that. The first number, the first fraction, stays the same. So negative 5/12 is still negative 5/12. But as you can see, because I drew some arrows here, the division becomes multiplication. And the fraction that we were dividing by, the one that's to the right of the division symbol, ends up becoming its reciprocal. Do you see here what a reciprocal is? It's where the numerator and the denominator flip, essentially. They basically change, position. So the 7 used to be in the denominator, now it's in the numerator. The 2 used to be in the numerator, now it's in the denominator. And now we can finish this problem by using the rules of multiplication of fractions, which is simply to look to see if you can reduce diagonally. Can we reduce the 5 and the 2 by any common factor other than 1? Nope, we can't. Can we reduce the 7 and the 12 by any common factor other than 1? Nope, we can't. So what do? We multiply the numerator times the numerator and the denominator times the other denominator. That will give us negative 35 in the numerator, 24 in the denominator. If you make that improper fraction become a mixed number, you would ask how many 24s can make 35. That would only be one of them. The negative goes outside on the left. And then how much would be left over? There would be 11 left over because 1 times 24 is 24, and that's 11 away from the 35. Your denominator stays 24, and there you go. Both the improper fraction and the mixed number version are considered simplest form, which is something I taught you on the multiplication of fractions and mixed numbers guided notes. However, I will admit, with most real-life scenario problems, the mixed number version would probably be simpler and probably would be easier to understand. All right, we'll skip number 2 for now. You'll eventually do that on your own. Let's take a look at number 3. Now, number 3 has mixed numbers. You might remember from the top, you must make them become improper fractions first. So here we go. 8 times 4 is 32, plus 3 is 35. 2 times 12 is 24, plus 1 is 25. You'll notice whenever I did that, I temporarily ignored the negative signs, and then I just threw them back on to the fractions. You can keep the negative symbols in the numerators. You could also keep them to the left of the fraction. Either way would be fine. You just have to realize the negative fraction, only one part is negative. The other part, in this case, the denominator, is actually positive. Because if you think about it, the fraction bar in of itself means division, and a negative divided by a positive gives you a negative value, which is why a negative fraction has one part negative, the other part positive. All right, sorry if I'm getting a little sidetracked here. What do we do from here? From here, we have to apply the rule that we just learned. Division is the same as multiplying by the reciprocal. When you do that, the first fraction stays the same. It does not reciprocal. It does not. First one stays the same. division becomes multiplication. The second fraction becomes its reciprocal. I like to keep my negative signs in the numerators. I could have put it in the denominator. There's nothing mathematically that says you're not allowed to do that. But traditionally, I seem to find that negative signs usually end up remaining in the numerator, so that's the way that I choose to do it. From here, once you make it multiplication, now you can apply the trick that we learned on the other packet of guided notes where we multiplied fractions and mixed numbers, and that was to look to see if there was a common factor that you could reduce by in any numerator and any denominator. So you would ask yourself, the 35 and the 25, do they have a common factor that we could reduce them by, divide them by? And yes, we could divide them both by 5. What about the 2 and the 8? Could we reduce both of them by something? Yes, we could. They're both divisible by 2. This will end up making the multiplication much easier. So 35 divided by 5 is 7. 8 divided by 4 is, 8 divided by 2 is 4. 2 divided by 2 is 1. 25 divided by 5 is 5. Still have multiplication in between. One thing I will warn you about, please be very observant and careful not to lose the negative signs as you do each step of the work, especially whenever you reduce numerators with denominators before you multiply. I've seen a lot of students who accidentally lose their negative signs, and that obviously will affect their final answer. So be very careful about that. From here, we will multiply numerator times numerator, denominator times denominator. A negative 7 times a negative 1 gives us a positive 7, and that will be over 20. As I taught you on the other guided notes, if you reduce as much as you can with numerators and denominators before you multiply, then your final answer will be in simplest form, which is really nice. This is the easier way of doing it, as opposed to multiplying first and then reducing last. That actually ends up giving you bigger numbers that you have to deal with in the numerator and the denominator, which is not as easy. That is why on the previous packet of guided notes, I recommended reducing diagonally, so to speak, whenever you could, once there's multiplication in between. All right, so I went over 1 and 3 with you. It is time for you to do numbers 2 and 4, the problems that I had skipped. So hit pause on the video, do 2 and 4, and then hit play whenever you're ready to see how you did. All right, I hope you did 2 and 4. Let's see how you did. Number 2, division is the same as multiplying by the reciprocal. That is the major rule of the day. Whenever you do that reciprocal, make sure this is now times. You're multiplying by the reciprocal. You're not dividing by the reciprocal. Please double check that. From here, you would look to see if you can reduce diagonally. With the 11 and the 3, do they have a common factor other than 1 that we could reduce by? No. What about the 4 and the 15? Do they have a common factor that we can reduce by other than 1? No. So we're just going to multiply numerator times numerator. That will give us negative 44. Denominator times denominator. That will give us 45. And that is indeed in simplest form, negative 44/45. Problem number 4. We have to make them improper fractions first. If you forgot how to do that, it's 8 times 1 is 8 plus 5 gives us the 13, still over 8. 4 times 9 is 36, plus 3 makes it 39, and so that's still over 4. Now, from here, do not try to reduce diagonally. You have to make it multiplying by the reciprocal first. That's something that sometimes kids forget. They'll try to reduce diagonally too early. You cannot do it when there's division in between. So, we make it multiplying by the second number's reciprocal. The reciprocal of 39 over 4 is simply just 4 over 39. Now, from here, we are going to look to see if we can reduce diagonally. Hopefully, you were able to realize that 4 and 8 are both divisible by 4. Hopefully, you were also able to realize that 13 and 39 are both divisible by 13. One thing I recommend checking is seeing if you can divide the numbers by the smaller of the two numbers itself. And that is the case here. 13 is divisible by 13, gives you 1. 39 is divisible by 13, it would give you 3. And so, look how pretty this problem becomes. Look how easy it's going to be to multiply. 8 divided by 4 was 2, 4 divided by 4 was 1. So our numerators, super easy to multiply, we will get 1. The denominators, super easy to multiply, and you get 6. The final answer is 1/6. If you did not reduce diagonally by 13, then you would have had 13 over, oh, I'm trying to do the mental math here in my head. I forget what it would have been over, but you would have had to reduce both them, the numerator and denominator, then by 13. So bottom line, it's easier to reduce before you multiply than multiply and then later reduce. All right, moving on. Problem number 5. This one is done for you on your guided notes, but let's talk about these real-life scenario problems. In the box, what kind of word problems will need division? Here's something to look for. Any problem where you have to find how many items of a certain size can fit into or come from a total amount, that's going to be your classic division problem. How many of these smaller pieces can fit into the bigger whole or the bigger amount total? That's what we're going to have here on number 5. Take a look at it. Each cheerleading uniform requires 2 7/8 yards of fabric. How many can be made from 74 3/4 yards of fabric? So this is the kind of problem where we know each uniform is only 2 7/8 yards of fabric. We want to know how many of those 2 7/8 could we get from a total of 74 3/4 yards of fabric. That's what I mean by this box. How many of a certain size, how many items of a certain size can fit into or come from a larger total amount? That is a classic type of division problem. But let me warn you, the order does matter. The total amount should be first divided by the amount that each of those smaller pieces are made up of. In this case, the 2 7/8. If you switch the order, your answer will not make sense because the order of division does matter. All right, so this one, like I said, is already typed up for you. We make them in proper fractions first. You can't forget to do that when you are dividing or multiplying mixed numbers. Then from here, we will multiply by the reciprocal. Please, again, make sure that once you do the reciprocal of the second fraction, that you make the division turn into multiplication. That is important. First fraction stays the same, as I said before. Then we look to see if we can reduce diagonally. Just like you saw on the previous problem, 8 and 4 are both divisible by 4. You should always check. Could 23 be something that 299 is divisible by? Believe it or not, it is, which makes this a lot nicer. That's going to give you 13. 299 divided by 23 is 13. We know 4 divided by 4 is 1. 23 divided by 23 is 1. 8 divided by 4 is 2. That's where these numbers came from. Now we multiply and we get 26 over 1, which you should know anytime you have something over 1 where your denominator is 1, that's just going to be the same as a whole number. So 26 over 1 reduces to just 26. The final answer is 26 uniforms. Remember what the problem said. How many? What are they talking about? These cheerleader uniforms. So that's why the answer is 26 uniforms. All right, time for you to hit pause on the video, read number 6, do number 6 on your own, and then hit play when you're ready to see how you did. All right, let's see how you did. Hopefully, you probably realize this is another division problem because we are asking how many servings can we get when we know each serving is 3½ ounces. How many of those 3½ ounce servings can we get from a total of 36 ounces of pulled pork? This problem's making me hungry. I don't know about you. So we are going to divide. Now, again, like I said in number 5, the total amount should be written first on the left, then divided by the amount that each serving is going to be made up of, in this case, the 3 1/2. As I said at the top in the box, you must make whole numbers and mixed numbers become improper fractions first. Now, you might be like, why is it still division, Mr. Underkoffler? Well, it's because we haven't done the reciprocal part yet. So one step at a time. If you end up being a kid who tries to combine the improper fraction step along with the multiplying by the reciprocal step, I am telling you that's a bad idea. Do not combine those steps. I've seen so many kids make really bad mistakes because they try to combine those two steps. So take it from me, the experience I've had, do these steps separately. All right, so as we learned, division is the same as multiplying by the reciprocal. Then we would look to see, is there anything we can reduce from a numerator and a denominator? 36 and 7, no. They do not have a common factor other than the 1 that we could divide by. And then 2 and 1, well, the 1's already 1. You can't get any lower than that, so there's nothing you can reduce that way. Now, I know some of you probably saw the 36 and the 2, and you might have wanted to reduce them by 2, but you can't. You cannot do the reducing diagonally trick when there is division in between. I'm telling you, you cannot. It does not work. I've tried. It does not give you the same answer. You can only do the reducing diagonally trick when there is multiplication in between the fractions. So that's something you're going to want to remember. All right, so we finished this problem. 36 times 2 gives us 72. 7 times 1 gives us 7. Now, with real life scenario problems, especially this one, the mixed number answer is going to make more sense. So in this situation, if you left the answer as an improper fraction, I would mark it wrong and take off a half point or a whole point, because you would never hear somebody say in real life 72 sevenths servings of pulled pork. There's no way you would hear that. You would hear a mixed number. So in this case, I would figure out how many 7s can make 72. It'd be 10 of them, with 2 left over, because 7 times 10 is 70. That's only 2 away from the 72, and that's how we get 10 and 2 sevenths servings. Yes, the word servings is required. You could even go further. You could say servings of pulled pork. That'd be even more clear. All right. Now we are at the second page. You can see a number 7. I did it for you. I wanted to give you number 7 as another example for you to look at, just to remind you that even though it was tempting to want to reduce the 10 and the 22 by 2, you can't, because there's division in between. Same thing could have been said about the 9 and the 33. They're both divisible by 3, but you can't do that because there's division in between. Moral of the story, you cannot reduce diagonally unless you have times in between. So that's one of the main reasons I wanted to give you number 7, just as a refresher to your memory that you cannot reduce diagonally until there is multiplication in between. All right, so what you should be doing now is 8, 9, and then also 10 and 11. Hit pause on the video, do those 4 problems on your own, then hit play when you're ready to see how you did. Okay, I hope you have done those 4 problems, 8, 9, 10, and 11. Let's see how you did. Pencils and erasers ready. Please fix any errors you might have made. Here we go, number 8. Well, we don't have any mixed numbers or whole numbers to make improper fractions, so we can right away make this multiplying by the reciprocal. As I've said before in this video, whenever you do that reciprocal, please make sure that you have times in between the fractions. Now, from here, you should check, is there anything that we can reduce by? Does 5 and 25 have a common factor? Well, they do. What about 18 and 48? Do they have a common factor? Yes, they do. Now, I apologize that I made this a separate step of writing. I honestly could have put the dividing by 5s up here on this step of work where I had multiplied by the reciprocal. So please know, this is a situation where I don't think it hurts to put this step right here where you multiply by the reciprocal. It should not affect your ability to get it right. I made it a separate step of work, but you do not have to. You can do it right up there where you multiply by the reciprocal. So anyway, as I was saying, 5 and 25 are both divisible by 5, so we should go ahead and reduce those. 18 and 48 are both divisible by 2. They're both divisible by 3, but the greatest common factor that they're divisible by is 6. And if you want these problems to be as simple as possible, you should try to figure out the greatest common factor. That's why your 6th grade math teachers spent time teaching you how to find greatest common factors. In fact, you might have learned that in 5th grade as well. I don't know. All right, so where did I get these numbers from? 5 divided by 5 is 1. 18 divided by 6 is 3. 48 divided by 6 is 8. 25 divided by 5 is 5. Look how easy the multiplication now would be. Can you imagine how annoying the multiplication would have been earlier? 5 times 48, 18 times 25, and then you would have had like these 3-digit numerator and denominators you would have had to reduce by, maybe even 4 digits. Not fun. This is why it is so nice whenever you can reduce numerators by denominators when there's times in between. It makes your life easier. All right, 1 times 8 is 8. 3 times 5, 15. And that is in simplest form. If you did not reduce diagonally by as much as you could have, then you would have had an answer that was not in the simplest form, and you would have had to reduce it further to get the same answer that I have, which is 8/15. And by the way, I wouldn't mark that wrong if you took the long way, or not the quickest way that I did, but you still ended up reducing at the end and got 8/15. I would not mark it wrong. I'm just trying to show you the quickest and easiest way of doing these problems in this video. All right, number 9. Do we have any mixed numbers? No. So we can make it multiplying by the reciprocal right away. Remember, the first number does not change. It's the second one that becomes its reciprocal. Now, from here, is there anything that we can reduce by? 7 and 16, do they have a common factor other than 1? No, they don't. What about 6 and 15? Oh, they do. They are both, 6 and 15 are both divisible by 3. Sometimes I've had kids who don't recognize their multiples of 3. Well, it definitely helps you if you do on this problem. 6 divided by 3 is 2. 15 divided by 3 is 5. Now the multiplication is considerably easier than it would have been before. Negative 2 times 16 is negative 32. Again, guys, watch out for negative signs. Do not lose them. 7 times 5 is 35, and that is in simplest form. Moving on, problem number 10. Now, on 10 and 11, we did have mixed numbers. So, before you multiply by the reciprocal, rewrite the division problem as improper fractions. Notice the division symbol is still in between. Very important. Should not be times yet because I have not reciprocaled the second fraction yet. All right, here we go. Now I will multiply by the reciprocal. And as you can kind of see from these little dark shades, I also at this point, since I have multiplication in between, I realized the 26 and the 22 are both divisible by a common factor. They're both divisible by 2. Now again, if you're like Mr. Underkoffler, why did you not divide the 11 and the 22 up here by 11? It's because you can't. There's division in between. This is something you guys are going to want to memorize. The trick of reducing diagonally, a numerator and denominator, that trick only works when there is the times in between the fractions, not division. All right, so finishing up this problem. 26 divided by 2 is 13. 22 divided by 2 is 11. This does make the multiplication a bit easier. Still not the prettiest multiplication in the world, but it is easier than it would have been if I didn't reduce by 2. 13 times 7 is 91, and 11 times 11 is 121, and that, believe it or not, is in simplest form. And the last one, problem number 11. Did you make the mixed number an improper fraction? 3 times 4 is 12, plus 2 is 14. Keep the negative in front or up in the numerator. Don't forget the whole number of 9. You need to make that an improper fraction as well, 9 over 1. Notice there is still division in between because we did not do the reciprocal part yet, which is what I'm going to do now. Division is the same as multiplying by the reciprocal. Now, from here, you would check, are there common factors that you could reduce by? Does 14 and 9 have a common factor that we could reduce by other than 1? No, they do not. And 1 and 3, you can't even think about them because 1 is already as small as you can get. So let's go ahead and multiply. Negative 14 times 1 is negative 14. 3 times 9 is 27. And that is in simplest form. And that concludes the guided notes on dividing fractions and mixed numbers. Thanks for watching. We'll see you next time.